Okay, now my sheet must be visible to you.
Yes, ma'am.
Yes. Okay. So let's start with the panel data. So first of all, I'm going to just revise it, what we have done previously. So just to brush up it, because panel data is related to regression only. So just brush up of whatever regression we have done. So first thing that what we have learned, we try to understand some basics about regression and the statistical properties of estimators. That means what do you mean by estimators? What do you mean by error term? That means what is dependent variable? What is your independent variable? What is your error term? And so we are able to differentiate between estimation, what is the equation, what are the estimators that we have done, and what will be your estimate. We try to learn the properties of best estimator. That means what are the blue things. We have learned everything about that. We also learn certain finer points which we have to remember while defining the model, such as there should not be any measurement error. You are able to measure each and everything over there. You should not take any variable which is not related to your model. So we have discussed all these things. Plus, after that, we also discussed that our model should be blue. That means it should be best linear, unbiased estimators should be there. And we discussed the various forms of regression model. We also understand the multiple regression, that what are the various multiple regression and what do you mean by control variables. And we did a little bit study about the goodness of it. We learned about R, we learned about R square, we learned about AIC, we learned about BIC, N and Q, maximum log likelihood. We learn about P value, we learn about F test. So how we are going to see that whether we other abstraction model that we have applied is a good model or not. After that, we also done the various properties of blue. If you remember, we have done many assumptions. We also checked if how to test the violation of assumptions. For example, we have done if there is an autocorrelation. So we will take one part of the autocorrelation as a independent variable. If there is a multicollinearity, we learned that we have to remove one thing. That means we cannot take both the variables, both the independent variables which are having the multicollinearity among them. So, and we learned everything in the stata as well as the R. But today, whenever we are doing the panel data, we won't be using R right now because I don't have this much of time so that I can cover both R and stata. And if you will say that for panel data, data is better than R. If you are going for your all these things for univariate analysis, R is better than stata. But for panel data, believe me, stata is better than your R. R will be having the commands, but stata will give you the better result. Why I'm saying the stata will give you the better results? In stata, it will be easy to compare. Suppose I want to compare whether the test of a fixed effect will be better or the random effect will be better, or what is the job of the Haussmann test, why we are doing it. So stata will do it within a one shot. And in R, you have to remember many commands, but in stata, what you can do, you can make a do file for that. And every time you are working on stata, just open that do file and just click the command, and it will automatically take it. All the do files will be stored in the your stata folder, and you can open the do file and then you can directly do it. But this facility is not available in R. In R, the facility is for the history. You can just click the history, but it will take all the whatever commands you are given, you have taken in R, maybe for 2 days back, 3 days back, 5 days back. It will merge everything in R. So you have to remember that this command is for this concept and this command is for that concept. But what does stata do? Stata, you can make a do file. In R also, I can make a do file. If you remember, I have told you about the script file. You can save that. You can save the script file in that. As we have to save in this stata, you can save the script file in R also, and you can make the data available in R. So if you are not if you're not known that how to make a do file, that I'm going to tell you, whether you are making in R, whether you are making in Stata, we can do the same concept over there. But normally what I do, I never save it for R because it takes lots of space. But if you are saving for Stata, it's not taking much space in that. Okay. So before I start further, do you have any question regarding the regression? That what is my bivariate regression, what is my error term, what are the different assumptions, what are the role of different assumptions. But whenever we are doing stata is again a form of regression only. So we will be working on all the parts of your regression. So you should remember all the parts of regression, all the assumptions. There should not be multicollinearity, there should not be heterogeneity, it should be homogeneity, should be there in the error term, and your multicollinearity, your autocorrelation should not be there. Plus your, we are not going to check right now in today's class about the stationarity because first of all, your regression concept must be clear. But yes, in some papers you will find out that stationarity is also taken care of. So no questions. Okay, now still I'm not going to start with the panel data because there are certain concepts of regression which I have still not covered. So first of all, let me cover those concepts also. Then we will move to the panel data because if all the concepts regarding your regression are clear, it will be more easier to work with the panel data. So I'll give you some of the challenges that you have to face with the panel data, or you can say a simple regression. So far, whatever we have learned is pretty much clear. So your first challenge. Now, I'm taking a small example for blood pressure and age. Do you think there is any relationship between the blood pressure and age? As the age increases, does the blood pressure increases? Does it changes? Yes.
Yes, ma'am.
So that means we can say that blood pressure and age having a some relationship. So if the
Yes.
age is changing, so my blood pressure can also change because as we grow older, we think that we are having this problem of high BP. Mainly people are having the problem of high BP. So that means we are saying as the age increases, your BP tends to increase also because there are various problems that every person is facing. So if I'm going to create a model, I'll create the model like this, that blood pressure will be equals to your constant term plus beta age plus error term. So over here, I'm saying that these are only two variables that I'm taking. This is my dependent variable and this is my independent variable. So do you think that blood pressure depends only on age?
No, ma'am.
So what all can be the other factors?
Work pressure,
Work pressure, okay,
unhealthy food habits.
unhealthy food habits. But do you think that these terms are sitting in error term that we have done it? That all those things that we are not taking, they are sitting in this error term. And what we have to do, if we have to create a good model, we have to take all those variables in my independent variable. So as you say that your food habits, does the food habits has any relationship with age? We know that yes, if the food habits are changing, my blood pressure is going to change. So does the food habits is having any relationship with age? If my age changes, does my food habit also changes?
Maybe, ma'am, maybe.
Probably, ma'am.
Maybe,
Yeah.
but
Maybe.
probably, but not for each and every person.
Yes,
But
yes, ma'am.
not for
Yes.
each and every person. Okay. Now
Yes.
this concept. Now let's say I'm taking the weight of a person and age of a person. So now we all know that as the age of a person increases, weight also increases. If a person is a newborn person, newborn child, he will be having a 3 or 4 kg weight. As the person grows up, the weight increases, and I cannot say that as compared to height, as our height increases normally till 20 years of age. After that, our height stops. So I cannot say this concept in case of weight and age. Even if right now, if you are at 40, 50, 60, 70, your weight is going to be changed. It depends. So, and even you will find people who are not eating much, they are not eating fried, but they are taking very care of their health, but still weight changes. So that means age and the weight are directly related to each other, isn't it? Weight change as the age changes, weight changes. Okay, so that means I can say that in the previous example, your blood pressure and your age is having a relationship. And this is you can say I have just make this regression analysis and I got this result. So these are my constant for age and this is my p-value. So p-value is since p-value is less than 0.05%. So I can say that age is playing an important role in depending or you can say in explaining my blood pressure. And you will see whenever we are seeing that which model is the best model, I have already told you what we are going to see. We are going to see R square. Second thing, we are going to see AIC. This is AKIK criteria. Its full form is AKIK information criteria. AIC, we are going to see log likelihood. We can see the sketch one criteria or you can see the NNQ. If you are observing the AKIK information criteria, NNQ or sketch one, you have to see the minimum value. If you are going to see the log likelihood, you have to see the maximum value. In this way, we can compare it. And for the model where the R square is more, we will say that that model is explaining those independent variables which are having the more R square that are explaining more the dependent variable. So if I have taken only age as a dependent variable, my R square comes out to be 61%. So I can say that age is explaining 61% of your blood pressure. But what we have learned right now with the diagram that age and weight are also related to each other. Age is related to weight. As the age increases, weight also increases. So I can say that weight is also playing some role in explaining the blood pressure, right? Weight is also playing some role in explaining blood pressure. If your weight increases, it's obvious the blood pressure it tends to increase. So weight is one of the factors which changes your blood pressure. That's why people say that your weight should not be more. If our weight is more, it's obesity, and obesity is one of the relationship with the blood pressure. I told you in the heart attack also, obesity was one of the reason. Your age is one of the reason. Your blood pressure, your smoking, your alcohol, these are the various factors. So if obesity and blood pressure are also related, blood pressure and smoking was related. So that means over here, blood pressure not only depends on age, but it also depends on your weight also. Now, see what I did in the regression equation, instead of taking only one factor as an age, I just took weight also as an independent variable. So if I took the independent variable of weight, you can see my R square has increased to 0.68. Previously it was 0.61 and now it's 0.68. So that means what we have to do, it's very important for us that we have to check all those variables which are related to my dependent variable. Now you can see over here what I have done. I have just make a comparison. Over here I have taken only age as a factor, as an independent variable. Now I have taken age and weight as a independent variable. So when I took age and weight as an independent variable, you can see that my R square is increased. It's 0.689933 and over here it's 0.610933. So that means I have to take this model. I should not take this model because over here 69, 68, or you can say on an average 69% of the factor why the blood pressure changes, it increases or decreases, is explained by your age and weight. But if I was taking only one factor, age, it was explaining only 61%. So that means this is the better model than this one. Now, what is happening over here? In the previous model, when I have taken only the blood pressure is depending on age, that
Ma'am,
way,
just a question.
yes,
In your previous slide, the standard error is showing 38 point something. Yeah,
where
36. Yeah, 36.69. The
hmm.
multiple variable. Yes, age and weight.
So now what you can say that over here my standard error when I was taking age, my standard error was 40. Now it has reduced. So I am moving towards the better model. Even
Okay.
adjusted R square has increased. You can see over here, adjusted R square is 0.59, now it's 0.66, now it's explaining 66%.
Okay, got it, madam. But the doubt is basically, suppose let's say 68%, so remaining should come in error, like 32% or 31
Yes,
point
yes.
something.
So that means there are more variables that I should include it.
Okay.
As more and more variables you will include, your standard error will decrease. Your adjusted R square will increase and your standard error will decrease.
Ma'am,
Fine, fine.
excuse me.
Yes,
Yes, ma'am. I had this doubt always. See, when we are, adding more and more variables, it gives a different answers. Like there's a
yes.
number. Even
Mm.
yesterday also we have checked in the ARDL model also that there will be a, see, when we are changing the lags, it is giving some other numbers. I mean changes in the values. So
Yes.
I just thought it may. I was not able to come to the conclusion why these are the changes.
See,
And said,
as
madam,
as more and more variables you are going to take in your model, you will
yes,
find
ma'am.
the changes because this is
Yes,
just a machine. It is
yes,
just a
exactly.
machine. As if
Okay.
I suppose I am taking the blood pressure, your age, your weight. Suppose add the my weight also over here. You will see that if I am taking one more variable of my weight, this adjusted R square will increase and this standard error will decrease. So we don't,
Yes,
the thing is over here, it says that we don't have to blindly add the independent variables.
independent
Whatever
variable.
independent variables we are adding in my model, they should
Hmm.
have some meaning over there. They should be able to explain the dependent variable, and that is clear by the theory. That means
Yes,
you have
ma'am.
to believe on some theory. For example, if I'm saying that share price is increased due to its own lag or due to its dividend, the company has paid the dividend. If I say that my weight is
Hmm.
increasing and due to that the share price is increasing. So do you think that weight has any role to play to this so that the share price is increasing? But
Yeah.
since this is just a machine, if I'll make one variable as weight, what I have done, I have just given the name weight. Machine does not, this R stator does not know what variable name is there. As more and more variables you will add, it will give you the result. It will increase your adjusted R square and it will decrease your standard error. So whatever model you are making, you should have a base for that. You should have a theory for that. That means we don't have to include any variable just for the sake of increasing my result. So
So
just make a backup with your theory part.
yes, ma'am. Yes, ma'am. So we have to see always these independent variables having a significant contribution to the dependent variable, ma'am.
Yes, yes,
Like
yes,
you have seen in the age and weight, both
yes.
the variables are influencing on the dependent variable.
Influencing on the dependent variable.
So in the model, we should have always the significant independent variables. Is it right,
Not
ma'am?
only the significant, no, it's not only that variable should be significant. Significant, it can be insignificant also for this particular concept or what these particular, you can say, observation that I have taken. Over here, suppose weight is not significant. So I cannot say that weight does not play any role in BP. In then this my particular problem, weight is not playing, but actually weight plays. So I can write it in my research paper that the results are saying that weight is insignificant, but still I can believe that from the previous literature, I have come to the conclusion that in my result weight is insignificant, but actually in real life, weight is a significant factor in explaining the blood pressure. And you can give the backup of the literature that these are the studies which find out that weight has a major role in changing the blood pressure. So it can happen. These are just the machines.
Yes, ma'am. Yes. Okay, ma'am. Thank you.
Madam, just an add up that the p value has decreased drastically. Could you just
Yes.
explain the p value?
The p value is, we just have to see the p value is, it should be less than 0.05. Over here also your p value is less than 0.05 and here also p value is less than 0.05. P value is just saying that level of confidence. Over here, if you will see, I can say that there can be a 3% error over here, but if I include one more weight over here, it's saying only 1.3% error is there. So my error is reducing. I'm confident. In the other way, I can say that over here I'm 97% confident that age plays the major role in the BP. And over here, if I include age and weight, I can say that age plus weight, both the combination plays. I am 98% confident that these two plays a major role in explaining the BP. That's also okay. So that means what is the mistake we are doing over here, that when I'm not including the weight in my regression model, so that is known as omitted variable bias. I know that this is a variable which can explain my dependent variable, but still I have omitted that variable. In my previous model, in my model number one, if I'll go back, in this model number one, I have not included the weight. So it means that is an omitted variable bias. So we should not do that thing. So if you are aware about any variable which plays a major role in your study, so try to collect the data for that variable also. Otherwise, you will find that reviewers will give you that why you have not included all these things. So first of all, go with the theory and just see that what are the major factors that are explaining your dependent variable and try to include all those variables. Okay. Now, what is the consequence? Consequence of your omitted variable bias is that we have seen this is a true model. I have seen that y, or you can say BP, is equals to your age and equals to age plus weight, and plus still there will be some factors which are sitting in the error term. Why I'm saying there are some factors which are sitting in the error term? Because my R square is not explaining the 100% result. It was still saying that it has improved from 61% to 68%, but still it is not 100%, and you will never find that I am able to take all my variables which are explaining my dependent variable. I myself will not be aware of some variables which are explaining my dependent variable. So what is happening in the previous model? This is known as underfitted model. And this will be your omitted variable bias method. And whatever results I am getting, that will be biased. Okay, what is this? This is mainly what we have learned. There should not be covariance. You remember my assumptions for regression? We said that there should not be any relationship between your regressor, or you can say independent variable, and error term. There should not be any relation. And over here, what we find that if I'm not including the weight in my as an independent variable, age is having the relation with your weight also. Over here, what I have done, I have taken my blood pressure. In the previous example, I took blood pressure is dependent on my age only. But weight was sitting in my error term. So weight is also related with the age because as the age increases, weight also increases. So over here, what we see that our assumptions are violated. Weight and age are related to each other. So I can say that my independent variable and error term are related. So what we have to do, this is known as observe. I have observed that this is one of the variable which is related to my age. So my answer will be bias. So omitted variable bias means it is a bias that appears in the estimated parameters in the regression analysis when assumed specification omits an independent variable that is correlated with both dependent as well as independent variables. That means the weight that is sitting in the error term that was related to the age also. As the age increases, weight increases. It is directly related, as well as weight is also playing some role in explaining your dependent variable. So weight is that part which I have missed it, which is playing a major role in explaining which is related to dependent as well as independent variable. So we should not do like that. So the first thing what we have to do while learning the regression, there should not be any omitted variable which is playing a major role, which has a relationship with the independent and playing the major role for the dependent variable also. So what you have to do, you have to take care of such omitted variables. Now, but if we are not able into position to observe the omitted variables, in this example, we are able to observe the omitted variables, but can we do something that if we are not able to observe the omitted variable, there can be some variables which I cannot observe. Can we do something for that? If it is observed, what I'll do, I will take it. But if it is not observable, what you are going to do it? Yes, anyone? If any data we are not able to observe, what we are going to do it?
Madam, usually we keep it in the error terms.
Mhm. So, but if it is in the error term, it will make your result biased because our assumption is there should not be any correlation. That means independent variable and error term should not be related to each other. Our result will not be blue. So if it is observed, what I'll do, I'll take it out. I can include it in the independent variable. If I'm not able to observe, then what we can do? So that means, so what we have learned till now, that this weight was sitting in this error term and it was related to the age. So we have included that thing. But now, what we have to learn that explanatory variables are given or they are fixed in repeated samples. Sometimes what happens, this is one, again, there is one of the assumptions that whenever some explanatory variables, whatever explanatory, for example, in our case, the age was the explanatory variable. So it is fixed. Your age is fixed and it will be repeated again and again by samples and samples. And what will happen if some variables are stochastic or randomly it happens? For example, I can say that demonetization. Demonetization happens and it is going to affect my country. Let's say I have taken the data for my country, I have taken the data for US also. I have taken the data for two different countries. So what will happen for the demonetization? I'm not aware about it. And even I cannot measure demonetization. How can I measure demonetization? If I can measure it, it is observable. I can measure it. I must have included in my as an independent variable. But I can just I'm not able to judge even that this can be the concept, but it can be a concept. Or what I can say to you, there are various factors. For example, you say that education, education of a person or experience of a person. If I'll talk about the education or our experience, I'll say the salary depends on the education of a person as well as experience of a person. It's obvious that your salary is going to increase as your education is going to increase. If a class 12th pass student is going to get a job, his salary will be less. And if a graduate is going to search for a job, his salary will be more. So I can say that education plays a major role for the salary. Plus, experience also plays a major role for the salary. But sometimes we can say that we will learning in the future that experience plays a major role, but it will be a quartic equation. We don't have to take x as an experience. We have to take experience as well as experience square, because it is not 100% sure that if I am having a 10 years experience, my salary will increase. Even a person who is having a 5 years experience can earn a better salary than a person who is having a 10 years experience. It depends from job to job. So I cannot say this. So it will be a quartic equation. So I will be taking experience as well as the experience square. So now we are going further for the stochastic regression. That means all those terms which are sitting in the error term, which are randomly coming. And that is the main problem of your regression. If we are not going to take care of those terms which we are not observable, which we cannot observe it, and that plays a major role with your independent variable, we name it as endogeneity. And in panel data, whenever we are going to learn the panel data, this endogeneity plays a major role. We name it as a fixed effect. So whenever that your learning is, whenever there is any unobserved variable which is sitting in an error term and that has any relationship with your independent variable, your endogeneity problem will exist, and we name it as a fixed effect. Endogeneity problem is for the fixed effect, and we have to learn two aspects: fixed effect and the random effect. Now, a brief thing for fixed effect, we are going to do it in the future. Fixed effect says that when some variable which is hidden in your error term, it's only related to one variable. In panel data, what we know that in panel data is a combination of cross-sectional and your time series. So let's say I cross-sectional, I am saying that I am taking the data for India, I am taking data for US, I am taking data for Australia. Three countries I am taking. So if any problem, if any variable which is sitting in the error term is just having any relationship with only one cross-sectional, we name it as a fixed effect. But if any variable that is sitting in an error term and it is having a relationship with all the countries, all the different cross-sectional, we name it as a random effect. For example, your COVID-19. COVID-19 is affecting each and every country. It is random. It is not fixed that I am going to touch India only or I am going to touch US only. So COVID-19 is random. It is affecting all cross-sectional, but I cannot measure it. And your demonetization is affecting only India, because in India only demonetization happens. It is not affecting US, it is not affecting Australia, it is not affecting your Singapore, New Zealand. So it is not affecting any other way. Or let me give you one more example. Let's say, okay, let's say your experience and the ability. And we are saying that as the experience increases, the salary increases. But it also depends on, we are saying education is one of the factors for your salary increase. I'm saying education is one of the factors. But if I'm saying about the education is one of the factor, it also depends on the ability of a person, isn't it? It doesn't mean that a person who is only graduate will be able to get a less salary and a person who is postgraduate will be able to get a more salary. It depends on the ability of the person also. Maybe a graduate person is more able to work to take up work pressure, maybe as compared to postgraduate. So ability of a person, I cannot measure the ability. So it is unobservable and unmeasurable. Or let's say I just give you a small example. Uh, let's say working condition, or let's say culture. If you see the profitability of a country, of a company, and a company is having the different branches throughout the world, so there can be, the culture can be one of the factor which is affecting only one country. The culture of different another country is affecting the profitability of that country only. I cannot say that the culture is that thing that is affecting throughout the world. Indian culture will not affect the US one. So Indian culture will affect the US, India only. So that means over here there will be a problem of endogeneity. The error term if some items are sitting which have a relationship with your independent variables. So now what is your endogeneity and what is your exogeneity? We have to learn that we cannot work with the endogeneity. The results will be biased. We have to work with the exogeneity. So exogeneity means that each x variable, that means your independent variable, does not depend on the dependent variable, rather y depends on x and y. That means I am saying that we have taken our example, blood pressure and your age. We are saying as age changes, blood pressure changes. I cannot say that blood pressure, due to blood pressure, age is changing. No, it's not a concept. Due to independent variable, dependent variable is changing, not due to dependent variable, independent variable is changing. So that means x variable does not depend on dependent variable y. Rather, y depends on x, as well as y is depending on your error term also. Now, since y depends on an error term, this means that x are assumed to be independent of y. Over here, we are saying x is not dependent on y, but y is depending on x. And so y is depending on x as well as e, error term. So I can say x should be the independent term. That's why we name it as independent. It is neither related to y, it is neither related to x, e term. So it is independent of e. So got our concept? Exogeneity means your independent variable is the independent term. It is neither related to your dependent variable and neither related to your error term. And if you find that your x, your independent variable, is related to your error term, we name it as an endogeneity. So it is required because if the independent variables are not independent of E and Y, then the estimated regression coefficient may not be unbiased and the consistent if we use the OLS. And if we continuously going to use it, our results will be biased. So regressors are said to be exogenous. Regressors means your independent variables are said to be exogenous if they do not have the endogeneity problem. And endogeneity problem means they are related with the error term. It means that exogeneity among the explanatory variables will exist if there is no correlation between independent and your error term. So over here you can see the symbols. These are your E stands for estimates. So estimate says that your error term, EIT means error term of an individual unit as well as time, is not related to the XI. It should be 0. If you are not going to find it 0, that means endogeneity problem is there. So that's why it's written for all i's, that means all cross-sectional as well as your time series, then regressive x are strictly exogenous. It means that each time period, the error term is uncorrelated with the regressor with all their lags and leads, that is uncorrelated with the past, present, and future values of the regressor. It should not be related, but if I give you this example for demonetization and demonetization, let's say I'm taking the example, demonetization happens in 2016, or let's say GST happens in India in 2017, and I am taking the data for 2017, 18, 19. These are the 3 years for which I am taking the data for throughout the country, different countries. So that means demonetization is affecting in 17 also, in 18 also, in 19 also. In all the 3 years, it is affecting. Or if I am saying the ability of a person, or let's say my teaching method, if I am taking the data for last 3 years or 4 years, 5 years, my teaching method that is sitting in the error term, I cannot measure it, how I'm going to teach it, my ability to teach. And it will affect if I'm taking the data for, let's say, 2020 also, if I'm taking the data for 2021, if I'm taking the data for 2022. And this is related to the experience if I'm calculating my salary. So the way you teach is related to your experience as the experience, because in 2020, in 2021, my experience increases. In 2022, one more year of experience is added. In 2023, one more year of experience is added. So my experience is increasing, but the ability to teach is directly related with the year. So it is affecting all the years. So that means in that case, homogeneous data, your error term is not homogeneous, it will be heterogeneous. So what we learned over here in exogenous, X is related to Y and E is also related to Y. Now, the problem of endogeneity is that endogeneity refers to a situation in which an explanatory variable is correlated with the error term. That's what we are doing. That whenever your any explanatory variable will be related to the error term, we name it as an endogeneity. Or in other words, we can say that absence of exogeneity means endogeneity. So endogeneity means correlation of right-hand side regressor with your disturbance, which is named as your error term. Or I can say that relation your covariance between your x explanatory variable and error term is not equal to 0.
Ma'am,
Then,
yeah, just a query here. Actually, explanatory, this is my independent variable,
yes,
and
yes.
how I will know that it is correlated with error term, because error term which I can't measure, or maybe there is a
Yes,
stochastic.
yes. So we cannot measure. For that, our tools are there. For that, I am saying that we are having the panel data. We have having the fixed effect. We have to run the result, and your tools will tell you whether there is a problem or not. Because sometimes we are not aware about. Suppose you are not aware about theory also. You are not aware because these are just the examples that we are explaining. But actually, when we are creating models, we are not aware about those factors which we forgot to include or which are related to your this independent variable. So that's why these tests are made, that with the help of these tests, we can judge whether there is a problem of endogeneity or not. If the problem, the results, obviously we are going to test with the p-value. And if we are saying that your uh, these are your independent variables and your error term is going to be correlated. So we automatically get the results by these tests. So they will tell me that yes, endogeneity problem is there. We are going to these tests are going to solve it. And if they are your values, p-value, if you are not getting p-value as per the hypothesis, they will say there is not a endogeneity problem. Everything is exogeneity. So these tests will tell you that how we are going to do it. Otherwise, if we are able to recognize it, so there is no need to make a model. Why we are doing all these things? So for these tests are being made. So your fixed effect model will tell you about your endogeneity, and fixed effect model will remove all these things. And we will learn actually how we are going to remove it. So what does the endogeneity say? Endogeneity says this your explanatory variable is related to your error term. Previously, exogeneity is that X and E are related to Y, but now we are saying endogeneity problem is X and E are also related, which should not be there. So now how we are going to solve it? So what we have to do, what is your strong exogeneity? We have to remember this thing. What is my strong exogeneity and what is my weak exogeneity? So strong exogeneity means your error term for all the individuals. Over here, individual can be person, it can be firm, it can be country. And your explanatory variables, that means your independent variables, it should be t minus s. That means it should not be related to all t's, whatever the previous lags. S means your previous lag, 1 2 3, for all s, 1 2 3 4 5, whatever serial numbers you are taking, a number of years you are taking. So neither it should be related to your past, neither to be future. So if it is equals to 0, that means it is not related to your past, x minus t. And again, if s plus t means future, it is related to 0. So that means that is known as strict exogeneity. That means there is no endogeneity. Your error term, whatever variables are sitting in your error term, neither they are related to your past, neither they are related to your future. So simply what we have learned in the strict and exogeneity, your error term is neither related to past nor related to your future. But if your error term, whatever variables are sitting in your error term, they are not related to your past, but they are related to your future. For example, I gave you my example. Let's say I'm teaching with the help of examples, but yes, when I started teaching, I was not aware about such example that comes there with the help of experience. So if I'm taking complete data, this ability to teach with the help of examples is not related with the past. So at that time, the correlation was zero, covariance was zero between the dependent variable and independent variable. But now it is not equals to zero. It is directly related to my experience. So this is known as weak exogeneity. Okay? So under weak exogeneity, error term is unrelated with only the past, but it is related with the future. Now, why this endogeneity happens? So we have already done why all these things are happening. First was due to omitted variable biasness. That means whatever omitted variables are there, that can be divided into observable and unobservable. Some variables can be observed, some variables cannot be observed. Or some variables will be related to cross sectional only, that means only with one part, and some are related to other than cross sectional. I give you the example for demonetization. Demonetization is related only to one specific country, so that is only to one unit. But COVID-19 is related to all the units, all the countries. So there can be something that some error, some part is sitting in an error term where I cannot measure. For example, again, your demonetization and your COVID, or my ability to, how can you measure my ability to teach? Will you measure that if I am teaching, I'm taking one example, I'm taking two examples, I'm taking three examples? You cannot measure it. So there will be various things which will be unmeasurable. Or suddenly something happens. There is a stochastic, there is a dynamic relationship. So there can be many reasons why the endogeneity happens. So the main point that we have to remember is exogeneity ensures that OLS estimates are blue. If your all the variables are exogeneity, your answer will be perfect. But endogeneity will create a problem of OLS estimate. So if endogeneity problem is there, my answer will not be blue. So that's why exogeneity is a friend of OLS while endogeneity is a foe for OLS. So if exogeneity and endogeneity we have to compare, we don't have to worry about your exogeneity, but we should be worried about endogeneity. Because what the endogeneity is doing, endogeneity is attacking your friend OLS, which is your exogeneity. So these are the reasons. So main thing is about my endogeneity. What is my endogeneity? Now, first of all, tell me any doubt what is endogeneity?
Is it the commonness, ma'am?
Endogeneity is clear.
Yes.
Okay. So let's move towards how we are going to take care of endogeneity. So what we are doing, endogeneity is caused by observable omitted variable. We have already taken care of in the case of your weight and age. So again, what we have done in the blood pressure problem, this was my age. So this problem, when I took the age, this model was suffering from endogeneity. But in this, the endogeneity problem, that means relationship between error term and your independent variable was observable. So what I did, this was weight was observable. So what I did in the next part, I included the weight also. So whenever your endogeneity problem exists and you can observe it, you can just include it. But what we are going to do when your omitted variable is unobservable? So now see over here, the example I was giving to you, that wage is depending on the education as well as experience. And you will see I have taken experience square because I know that as the experience increases, wage increases, but it's not 100% sure that every person's experience, the experience increases for each and every person, wage will also increase. So that's why I have taken experience square, because whenever we are taking, it will be a curve over here, and with the same experience or with the same revenue, with the same wage, you can find a person with 10 years experience, and with the same wage, you can find a person with 20 years experience also. So since 2 points will be there whenever we are making a diagram, or I can show you like this. Let's say if I'm going to make a diagram, let's say if we take a diagram over here, I am saying that these are your experience. This is my experience. So this is your experience and this is your wage. This y-axis is your wage. So I am saying that wage is increasing as the experience is increasing. At this point, your wage is increasing. Then let's say this point. But it can also happen that your experience is increasing. Over here, your experience is 10 years, over here is 20 years, but still your wages are same. So this can also happen. The wage remains constant with 10 years experience also and 20 years experience also. So that's why you will see it comes to be, there will be like the same wage. There are 2 points over there. So we name it as a quadratic equation. And that's why I have taken experience and experience square. And whenever you will be making a diagram, it will not be a straight, it will be a curvilinear type. Something this will be like this. Even you can have one more curve and this will be making as, we can also take a cube depending again on your theory. So it can be a curvilinear path. So now over here I am saying there is the ability of the working woman on which is sitting in my error term. The ability of a person. That and ability comes with the experience as well as from the education. So ability is sitting in an error term which I cannot measure, I cannot observe. So what is the issue? That the person's ability or the intelligence may affect the wage of that person, but it is difficult to observe. Now, what we can do? Because that is sitting in a error term. And whatever your education is there, education may plays a major role in explaining the ability of a person. So that is the main problem of endogeneity. So again, we have already discussed about exogeneity and endogeneity. Now see one more problem over here. Now, if your OLS estimates will no longer be blue as the individual cross-sectional unit is observed repeatedly over a period of time. And there is likely to have an error to be the cross-sectional units are correlated. These cross-sectional units can also be correlated among them. This we are taking for a district 1 only. This is for the 1 district, 2nd district, 3rd district. And every year, birth rate is related to each other. So again, this can be one of the problems. So what we have learned, we have faced two kinds of problem of endogeneity. One is endogeneity problem due to omitted variable bias that we can include it, and correlated error problem due to repeated observation of the cross-sectional unit. Okay, so this we have done case 1. Case 2, we are going to discuss about the case 2, and case 3 will be there. So whenever we are saying that your endogeneity problem is going to address, there will be the heterogeneity. Because let's say if I'm saying about COVID-19, COVID-19 will not affect equally to all the countries. If you remember about homogeneity and heterogeneity, homogeneity means equal variance. It is going to affect equally to all. But heterogeneity says it will affect differently to different persons. So over here, if COVID-19 is there, it is affecting differently to different countries. So heterogeneity will be there. And even if I'm saying about your ability of a person, it is also heterogeneity. My ability is different, your ability is different, some third person ability is different. So it's different for everyone. So what we have done, we are going to do it with the help of fixed effect model. So these fixed effect models that we are going to create will take care of your omitted variable bias by considering unobserved cross-sectional heterogeneity. And now we are going to learn the panel data. And whenever we are doing panel data, we will have the two agendas right now. Either it says a fixed effect or there is a random effect. And I hope so your fixed effect and random effect must be clear. Fixed effect means it is affecting only one cross-sectional and it is affecting only one unit, maybe one individual, maybe one firm, maybe one country. But your random is affecting everyone, all the cross-sectional that you have taken. And fixed effect is also known as within estimator. Why I'm saying within? Because it is affecting only one. If I'm saying my education, I'm taking my individual, my salary, I'm taking your salary. There are two individuals I am taking and the data is for let's say 2020, 2021, 22, 23. That means 4 years for one individual and same 4 years for the second individual. So my ability is affecting only me. So it is affecting within one cross sectional only. Your ability is affecting within your cross sectional only. Your ability is not affecting my cross sectional. Even my ability is not affecting your cross sectional. As I told you about demonetization, if I'm taking two different countries, let's say I'm calculating GDP or revenue generation. So demonetization of India is affecting n number of years, maybe whatever years I am taking about the demonetization. Demonetization effect can be last for 2 years, for 3 years. So it is affecting only one cross-sectional within 1 year by one country. So that's why we name it as a within estimator. Fixed effect is always named as a within estimator. And random, since random is affecting all the countries, we name it as a between estimator. So let's move towards the panel data. Panel data, there will be two period panel data or multi-period. As we have done in regression, there can be bivariate regression also, there can be multivariate regression also. Similarly, in panel data also, there will be two period. That means two period means I am doing a comparison. I am taking that T should be equals to 2 only. Your cross-sectional can be many. I can take 5 individuals, I can take 10 individuals but I am taking only 2 time periods. And in multiple time periods, your T will be more than 2. Now, see this model. Now, what we have learned in panel data, you are aware there will be, till now what we have done YT only. Because we have learned the time series and we are observing the univariate variable only. I am saying that Y is related to time. But now what I am doing, I am saying Y is related to the units as well as time. So that's why I am writing YIT. X1 IT, B X2 IT. That means second variable, your second independent variable. Similarly, K independent variable. And what I am saying, this is my error term. This is my error term. AI and UIT. AI means some variables which are sitting in the error term, which is only related to one individual. It is not related to time. My ability is not changing with time. Even if in the next workshop, if I am going to teach, my ability remains same. Even if after 10 years, my ability remains same. So this is related to me only. It is not related to other individual. Neither it changes with time. It is not going to change with time, your ability. Or if I say that in error term, my qualifications are there. Qualification, and from now onwards, I'm going to take next 5 years. My qualification remains same. Every year, my qualification is not changing. Experience changes, age changes, your qualification is not changing. Rare cases, we are not considering each and every case a person can learn, can change the education, but at some point, education remains fixed for the further number of years. So I am not taken T over here because it is related to individual only. It is not related to your time. And UIT means your individual as well as time also. And this alpha term, alpha I, this is a problem of individuality. So we have to recognize this thing. And this model is called as fixed effect model. We have to get rid of this. We have to get rid of this. If we are going to take it out from our model, then we can say that my independent variables are not related with the error term. And this combined AI plus UIT is known as combined error term. This part AI I am not able to observe, and this is related to my XI. So what I'll do, I'll try to remove it. How we are going to remove it, that we are going to learn. So, but we have to note, you have to note that whatever effects are omitted variables have it on individual units at one time, they will also have the same effect in the later time, and we name it as fixed over time, as I told you. My education is fixed over time. My ability is fixed over time. Or let's say if I say that uh, uh, let's say how happy you are if there are two, I take the location of the house, two different houses, and one house has a location where you have you can see the outside beauty, that means you can see the trees and something like that, but there is one location of your house which is compact and you are not able to see the outside world. Actually you are not able to see in front of your house there is a concrete building. So again, that will be fixed over time. For today also, tomorrow also, day after tomorrow also. Or culture. Culture is fixed over time. For each and every country, your culture is fixed over time. So whenever there is a problem, that is being taken up care about by the fixed effect model. So it is assumed that fixed effect that the omitted variable must have a time invariant value. Time invariant means as the time changes, this will not change. So fixed effect estimator allows the correlation between omitted variable or time invariant variable with the observable in explanatory variable. It will take care of. So now we will learn by the help of your normal manual also how we are going to do it and how we are going to do it with the help of this data also. So I have already told you that fixed effect is also known as within estimator. And one of the way is one of the methods to solve it by least square dummy variables. What it says that we will create a dummy variables for all the data. For example, if I am taking the variables for, let's say I'm taking the data for 5 years. So for each year, I'll take one. If let's say I'm taking the data for 2020, 21, 22, 3 years. So I'll say for 2020, it should be dummy variable will be 1. For 22, 23, it will be 0, 0. Again, I'll take one more for 22, 22, I'll take 1 and 21 and 23, it will be 0. And again, one more dummy variable, 23 will be 1 and 22 and 21 will be 0. So we will be take as n will be there, number of periods will be there, we can take as much as dummy variable. So there are two methods. Either we can do it by least square dummy variables or we can do it by fixed effect. And mathematically, both the methods will give you the same result. So least square dummy variables, we can take the help of dummy variables, as I have already told you how to take it. And that will, but the problem is when the n is very large. If you are taking n is dummy variable, let's say I'm taking 20 years, 30 years, 50 years. So how many dummy variables you are going to create it, then you will face some problem. So let me move directly to the fixed method, and that I have already told you that this is the within estimator. So now see how we are going to do it. Now, as I told you that whatever the problem is sitting in your variable is sitting in your error term, that is time invariant. It will not change with the time. So what one of the method is, you just take the average and just subtract the average from all the variables. And if you are going to subtract the average, you will see that AI is subtracted from AI, it will be cancelled and it will be ruled out. And your now whatever the variable you are going to get, whatever the equation you are going to find, that is not related to your error term. So that means we have removed the endogeneity. So this is one of the methods that the fixed effect is going to do it. Okay, let me directly move towards your now let me show you this Excel file. I have given you one of the file related to wage and experience only. Now in that file, you will find these variables. So I have taken different individuals in that, but just to explain how the fixed effect is going to work, I have just taken the only one cross sectional. So this is the employee number 13. These are the employee number 13, employee number 17, 18. I have given you many employees numbers by which the salary is being decided. This is the years we have taken from 1981, 80 till 87. That means 8 years. And these are the number of hours worked. This is the education. Now you can see education is also time diminished. It is not changing with the help of number of years. 14 years of education means over here 12 plus 2 years. Your 13 years education is 12 plus 1, 12 years education is your 12. So similarly, we have taken the education and it is time diminishing. Time is changing, your education is not changing. This is your wage, log wage. Now, what we are doing, I am saying that there are some factors, let's say, that is depending your some AI. AI is there, which is having the effect on your wage. So what you are going to do? Let's say art. Art is one of the factor, or education is one of the factor, because it is time diminishing, which is sitting in the error term. So how I'm going to get the fixed effect? First of all, what you are going to do, you have to total all these things. If I'm going to see, you can see that total. If I'm going to total it, you will see if the sum is 22461. The total is 22461. Then I'm going to take the average. So 22461 divided by your 22461 divided by 8, because 8 years are there. Similarly, what I did, I'll calculate for education also. I'll calculate for log wage also. And after that, what I did, whatever my average is there, I write it over here for wage, for hours, and for education. And after that, I minus it from the wage, log wage, minus average of log wage. From hours minus average of hours. From education minus average of education. And when we did like this, my education becomes to be 0. And if education is still, education will be omitted now. Education is gone. That means what I have done, this is the fixed effect. I have demeaned the time. The same thing what we are doing over here is the same thing that we did in your univariate analysis. We remove the stationary, we remove the trend. So over here, we remove the education because it is time demeaned. So this is one of the way. Either you can do it manually, and if you don't want to do it, obviously we cannot do manually. So that's why our models are there for the fixed effect.
Madam, one question that I mean, is it a kind of differentiating we are doing?
Yes, yes, sir. But differencing is there whenever there is only two variables. If you remember, I have just explained you, we have two kinds of data, panel data. When T is 2 only, that means let's say I'm taking 1980 and 81 only. Time is 2, so we will name it as a simple differencing. But when the time is not 2, it is more than 2, we name it as a fixed effect. We use the average method then. If you remember, whenever you are calculating the standard deviation, what is the standard deviation? We calculate the mean, we take the average of it, and then we subtract by the observed number of variables, and then we get the difference. So the same way we are doing in this only. So what we are doing, we are just making we are demeaning those factors which are not effective because age is constant throughout. So we are just removing it. Okay, now I'll be moving to Stata. So this is one of the screenshots. So you will see that whenever we are working on Stata, it will give you the answer for R square for within, between, and overall. So whenever we are working on fixed effect, we will take within. If we are working on random, we will take about the between, or we can also take about the overall. Overall means everything. So you have to take care of whether you are doing the fixed effect or you are taking the random effect. So R square means your overall, between R square means your mean of y for each y and predicted, and as I've told you how we have done it. And your between means your two different countries, two different i's, so you can two different individual, and within means within itself. And whenever we will be doing in Stata, we have to take care about this F statistics also. Second day, whenever you are doing your Stata, the results will be, you will find the correlation. It will mention the correlation. And if it is a correlation is there, that means endogeneity problem is there. So we have to apply the fixed effect model. And you will find the F statistics also. So these are the different parts that we are going to study. And what we have to do, and we are going to, there's whenever we are doing, as I have already told you, that if we are doing the least square dummy variables or we are doing the fixed effect estimator, that is one and the same thing. They don't have any difference. Okay, let's move to so that is also clear that we have two ways. Either we can use by fixed effect or I can use by dummy variables. So what we have to do, we have to estimate the time invariant variable. I have given you the example from Excel. Okay, this is okay. So the main thing we have to consider is that the effect of unobserved omitted variable is the main problem. Effect of observed variable is bad, but if you are not able to omit if the variable which you are not able to consider, that is good because we are not available, we are not able to judge it. But if you are able to judge it, you have to include it. It's bad if you are able to judge the variable which is observed but we have not included, you have to include it. But if you are not able to observe and you have not included, so it's good, that can be taken care by the fixed effect model. But if the observable variable is there, that will not be taken care by fixed effect model. You have to include it over there. So I have already given you these examples that your impact of experience, number of hours worked, education, your marital status on the wages earned by different workers at different time periods. If obviously if I'm saying marital status is not going to change it. So if a person is married, it will remain married throughout the time period that we are taking. So we can demean such things. I have told you about the within, I have told you about the between, and if within plus between is there, we name it as an overall. So these are just the things. So within means only for one individual. For all the years, this will be your within. If I'm taking two variables or two or three variables, this will be named as your between variations. And if you take overall, it will be your total variations. And your education. And over here, I've taken the example of Northeast. That means these are the people. I have taken the data for 13 number of individuals. This is the number, 13 number. I have given, let's say you can say individual 13, individual 17. Individual 13 is from Northeast. Your individual 17 is also from Northeast, but individual 18 is not from Northeast. So I have taken a dummy variable. I said that all those people who belong to Northeast, that will be denoted by 1, and all those people who are not belonging to Northeast, that will be denoted by 0. So these are your invariant variables, which will not change with the change in time. So we can remove it. We can omit those variables. If I'm going to omit those variables, I will be able to capture my fixed effect. That means your independent variable and error term will not be correlated there. So as we have done, these will be your time invariant, and plus I have taken a dummy variables also. You can take, I have over it, I have taken the dummy variable for Northeast, or even you can take a dummy variable for married and non-married, or even you can take a dummy variable whether the person is working in a manufacturing company or non-manufacturing company, and you can take dummy variables for year also. So that is known as, we are taking a dummy variables, it is known as time dummy variable. So this I have already told you that these two will be your correlated error term. That means co-error term. These are two error terms. One AI will be related to your independent variable, but UIT will not be related to your independent variable. So that's what we have to take care of. So now, whenever we are doing these regarding our unobserved variables, there will be two conditions. Either AI, that means the variable that is sitting in your error term is correlated with your independent variable, or it is not correlated. So only two things will be there. Okay, so let me move to stata. This we have already done. Examples I have already given to you. Okay, let's move to stata. And let me import my file. Okay, I have imported the file. I have made the do file also for this. Okay, so it's easy for us that what we can do, I have just made a do file, and we all are aware that your panel data is a combination of cross-sectional and your time series. So that's why it will be represented by word XT. Whenever we were doing our this time series, we always start with TS, time series. Over here, we will start with XT. So the first thing is that what I have to do, I have to give the command XT. So it will tell me that my panel data is from 1980 till even 1987, and it's a yearly data. So let's go with the next command. Let's say describe. If you remember in time series, it was my summary. Now over here, I'm saying describe. So it's going to describe me that what is my frequency, percentage, cumulative, how many years are there, how many numbers are there. So I have taken employee number 13, 17 till employee number 1, 2, 5, 4, 8. And I have taken the years, and you will find each and every variable name it over here. I have taken dummy variables for the time also, and I have taken dummy variables for the married people or not, Northeast, as I have told you. Okay, if you are going to get the XP sum, again the summary for year education and us, you will see the complete summary. This is the overall between within, and you will find the standard deviation for all the things. Okay, XP black means if I have to take only one variable, black means I have just done a survey that the wages of the black people and the white. We divided the complete. This is related to different countries. So it is all those people who are black, we name it as 0, and all those who are white, we name it as 1. This is a dummy variable. Now, first thing is let's uh, how to make a graph in this. So it depends because there are this panel data consists of many people. So we can do it either you can make for all, or you can say that I want to make a part of the panel data diagram. So what I have done over here, I'll have given the instruction just make the graph of all those employees whose serial number is less than 120. Now you can see whatever variables I have taken the employee number 13, 18, 110, 17, 45, and 120. So you will get the diagram for that. And if I'll give it a greater than sign, let's say if I'm giving you this sign, I'll just give you this do file so that it will be easy for you also. So it will give you, okay, I have again taken for 120 only. Now, previously I have taken for wages, now I have taken for hours. So whatever variable you want to make, you can make it. Okay, now you can do the pooled OLS. What we have to do, we have to just regress it. You just make a regression over here, it will get the answer for complete pooled OLS. Whatever regress, these are the old commands. What we are doing, we are just writing all the variables over here. So what we can do, we can store it over here that I was telling it to you for the pooled OLS. What I have done, I have stored the command in the variable POLS. Similarly, I'll do for fixed effect also. So I'm giving the command for fixed effect also. So again, I'm going to store this command in some variable. And let me give you the variable. I have just stored the command in frop. So the command for this is also stored in frop part, and now make it for random effect. Let me do it for random. And let us store this command also for somewhere. So whenever you are storing, we have to make the word estimate over here. Now it is stored in this. And now let us compare it. So comparison in all the three. Now these are the statistics that I want, and means your number of observation R square is you are available, you know, R square O means overall R square B means between R square, and REW means within. So these are the, you can see all the results are there for POLS, REROP, and FE. Now, what to do if I'm not aware that whether it should be the fixed effect or whether it should be the random. I'm not aware that in this in error term, whatever the variables is sitting, whether it is affecting only one particular cross sectional or it is affecting all the cross sectional. So what I'm going to do in that case, this Husman test is going to help us. So let us again calculate for, I'm taking first of all, I'm saying RE is there, and then I'll make it for FE. Commands are same, and again I'm storing the estimates in RE. I stored it in RE, now I'll do it for FE, fixed effect. And again I'm going to store the commands of fixed effect in FE. So I've stored the commands in FE. Now, after that, I will apply the Husman test. And Now you can see over here, Hussman test results is there. What it has done, it has calculated FP, it has calculated your RE. Then it has calculated the difference between these two and standard error. Now, whenever we are doing the Hussman test H0, null hypothesis says that there is no difference. That means HE and RE are same. If HE and RE are same, that means there is not a problem of endogeneity. When the problem arises when RE and FE are different. So the problem of endogeneity will be there. And you can see that the problem that your P is less than 0.02. So that means problem of endogeneity is there. If the problem of endogeneity is there, so we have to go with the FP only. So whatever the results of FP are there, if you will see the results of these are the results for FP. So I'll go with these results over here in FP. You can see that education is omitted. It has already done, everything is done. It has come out to be 0. And if I'll go with my Excel also, my education was 0. So this is the manual part that I have done it. And this is your software has done it for me. And if your over here in Hussman test, if you get the value to be more than 0.05, it means I can apply for the random effect. So I'll use my this answer. Now, any doubt? Any doubt to anyone? I know that today I was little bit fast because I have to cover this part. Any doubt? Nothing?
Doubts are
Madam,
there, ma'am.
still
Hello? So here we comes to the end of our workshop. Hope you have learned it.
Thank you, ma'am.
Okay. Can I have one photograph with your cameras on? Okay, now I'm stopping it. I'm stopping the recording.